Hi everybody, this tutorial is going to introduce us to a very important mathematical exercise called powers of 10. The motivation for doing this is that, as we see in our first few exercises, in physics we're trying to understand the universe, everything in the universe. And we want to measure things, distances, masses, times, etc. So to get an idea of what's in the universe, we've got to ask ourselves what's the extremes, what's the biggest, what's the smallest in terms of each, and then the easiest way to represent them are powers of 10. Rather than writing big long decimals or large numbers with lots of zeros, we shorten it with powers of 10. Something you've learned in math. I just want to make sure we are all on the same page to make our lives a lot easier. That's the background. Before we move forward, make sure you have your calculator available so you can do some of these things, and your reference tables, all right? So you should have uploaded up reference tables, either printed them out or have them available if I haven't given them to you already. So with that in mind, let's get going. We're going to start with just basics of scientific notation and prefixes, okay? You are expected to not memorize prefixes like kilo or milli or mega, but be able to find them in your reference tables. So on the bottom left hand of the front page of your reference tables, you will see a box that tells you what prefixes are, anywhere from tera down to pico, okay? So those are just simply powers of 10 that generally go up by 3 orders of magnitude, 3, 6, 9, 12, etc. Why they chose to do that, I don't really know, but it's the standard. So find the mega symbol, okay? So that's towards the bottom, capital M. And if you look at that, that prefix means 10 to the 6th, right? Or something of something, and that's 1 million. Okay, so not hard. You don't have to memorize that. And then you have something called micro, where its symbol looks like, well, a little m. It's really the Greek letter mu. Okay, and that means 10 to the negative 6. 1 divided by 10 to the 6, or 1 millionth. Okay, oops, 1 millionth. So it's a million times smaller than 1, and another million times smaller than a million, or a trillion times smaller than a million. In fact, if you divide those two, 10 to the 6th divided by 10 to the negative 6th, you can do that in your head or on a calculator, you get 10 to the 12th. Okay. So, suppose we find or are told that a virus has 80 nanometers wide. Take COVID. I don't know what COVID is off the top of my head, but it's on the order of nanometers. Okay? So what is its width? What does it mean in meters? Okay, so if the standard unit of measure is meters, what is 80 nanometers? Well, that's pretty straightforward. So if I look at this prefix, the 80 is that, they're still there, and we just got to look up what n means, nano. So go to our reference tables down the left, we see nano means 10 to the negative 9th, billionth. You don't have to know that means billionth, but it's helpful. So that's just 80 nm is a shorthand way of saying 80 times 10 to the negative 9th. Now, if I have to plug it in my calculator, I want to plug in this whole number, and now I'm going to show you the smart way of doing that. You might say, well, I already know how to do that. Well, in my experience, a lot of kids do the more difficult way and often the wrong way. So the way to represent scientific notation in your calculator is the EE button. Okay, I cannot stress that enough. Stay away from the 10 caret or the 10 to the x button. It will work, but you got to use parentheses in that, and very often students will make mistakes. So you have the special button that simply takes care of exponents. And if you don't say, well, I don't know where that is, that's simply the second button and then the comma. So if you look above the comma sign, you will see the EE button. Okay, so what that means is if I want to type in 80 times 10 to the negative 9th, I would type in 80. And normally many of you would do 10 caret negative 9 or 10 to the x, but don't do that. Press the second comma button, which will bring up an E, and then just the negative 9. That means 80 times 10 to the negative 9th. And it's really nice. Okay, so let's do practice. Reference tables. Find the ratio. Ratio is an important term in physics, and it's a little bit different than math. It's ultimately the same, but it's just expressed differently, of a gigaton to a kiloton. Okay, so we're using the prefixes and translating them to powers of 10. So giga, looking at reference tables, is 10 to the 9th. Billion, kilo, somewhat more familiar, means 1,000, which is 10 to the 3. Ratio in physics means divide. All we want is the quotient. We don't need to write 2 to 1. We're not interested in that. We just want to know when you take those two numbers and divide them, what do we get? So 10 to the 9th divided by 10 to the 3. Well, you subtract exponents, that's simply 10 to the 6th. So a gigaton is a million times bigger than a kiloton. Not that you need to know that off the top of your head, but we just want you to be able to look up those prefixes and then manipulate those numbers. All right, find the ratio of the mass of a proton to the mass of an electron. So in chemistry, you should have learned protons a lot more massive than an electron. What is that ratio? How much bigger? Here we're going to need our reference table. So if you look in the top part of your reference tables, are important numbers, and you'll see that the mass of a proton is 1.67 times 10 to the negative 27th kilograms. And the mass of an electron, 9.01 times 10 to the negative 31 kilograms. So what I want you to do is type these two numbers into your calculator using the EE button and come up with an answer, okay? An exact answer that you put into here, and then all I did was round it. I rounded to 1800, which then I translated to scientific notation of 1.8 times 10 to the 3. Okay, so do that and make sure you can get that right using the EE button. I'm not going to do it. I'm not going to give you the exact answer, but you should. So I'm going to pause. I want you to try these three right now. Okay, take 2 or 3 minutes. You will need your reference tables to look up the speed of light. That's again at the top of the reference tables. I've given you the speed of sound here because the AP doesn't give it. And then give your answer in scientific notation. The answers are on the back of the sheet. If you don't get the right answer, try it again. You should be able to get it right. If it doesn't go right, then you can always ask me. Okay, last thing I want to finish up on is this concept of orders of magnitude. You'll hear that term here and there. I want you to know what it means. I'm not sure if you've been taught that in other science classes, okay? So an order of magnitude is just a fancy way of saying a power of 10. So in other words, let's say I have 10 to the 5th of something. Cats. All right? So someone asked me, on what order of magnitude, how many cats do you have? What order of magnitude of cats do you have? I would say 5. 5 simply means 10 to the 5th. It's just a shorthand way of saying 10 to the 5th. So if I say that, let's say the mass of the Earth is 6 orders of magnitude, let's say 5 orders of magnitude greater than a human, what I'm trying to say is the mass of the Earth is 10 to the 5th times more massive than a typical human, 10 to the 5th being 100,000. So, for example, how many orders of magnitude are a tera and a pico respectively? All right, so tera, if you go to the reference tables, is a prefix that means 10 to the 12th. Okay, in other words, 12 orders of magnitude. Pico is, if you will, the obverse of that, 10 to the negative 12th, inverse I should say, and that's negative 12 orders of magnitude. So the ratio of the two is 10 to the 12th divided by 10 to the negative 12, which is 10 to the 24, which is 24 orders of magnitude. And when we start doing estimation, we'll see that looking in terms of numbers is rather helpful. Last problem. A heart cell is 1 micrometer in diameter, and a heart is about 10 centimeters in diameter. Okay, so how many orders of magnitude is the heart's diameter to a heart cell's diameter? It's the same problem as above. In order to do this, we want to have a common unit. So we want to convert micrometers to meters and centimeters to meters, and that's where knowing those prefixes helps. So 1 micro, look up micro on the reference tables. We did it earlier. That's 10 to the negative 6. So that's simply 10 to the negative 6 meters, or 1 times 10 to the negative 6. Centimeter is more standard. That's is it even on the reference tables? Oh, it is. That's nice. So that's 10 to the negative 2. A hundredth of a meter. So the ratio of the two is negative 6, 10 divided by, I want to do the reverse. I want to do the larger object divided by the smaller object. And to subtract those exponents, I get 10 to the 4th, 10,000. But I want it in orders of magnitude, so it's 4 orders of magnitude. All right, so there's your introduction to powers of 10. We'll relate that to some of the exercises we do in the very first few days and throughout the rest of the year.